Today we'll be focusing on how the Kaleido Information Engine can be used to increase the agility of prescription benefit management reporting by allowing business analysts to collaborate with data architects to add new information quickly when the existing data set cannot provide all the details analysts need to make decisions. This is a Kaleido business information model for analyzing prescription benefit claims. The model captures requirements graphically, enabling business and technical teams to work from a common understanding of requirements so they can collaborate better than ever before. Through automation, the model creates and manages the data warehouse, enabling requirements to be implemented faster than with traditional warehouses built by writing custom code in ETL tools. Claim event transactions are represented by the rounded box in the center of the model. Lines of the same blue color link it to the tan square boxes. Those square boxes define the reference data necessary to analyze prescription benefit claims at the health insurance payer. The company's claims, prescribers, pharmacy organizations where prescriptions are being filled, as well as the medicines being prescribed, for example. There is also a time dimension which Kaleido includes out of the box. The three lines from claim event to time describe the different rules for time that can be used for analyzing claims: the date of the injury, as well as the date the prescription was written and the date it was filled. The blue boxes inside the tan ones describe the various hierarchies and business rules of each of those types of data. For example, claims may be analyzed at the pharmacy and the chain level. The dashed line in the model tells us that not every pharmacy must belong to a chain. However, any pharmacy chain to which a pharmacy is a member must be known to the warehouse. Likewise, in the prescription dimension, prescription drugs may be analyzed by how the DEA classifies them. A business analyst is looking at a basic report of prescription claims for 2011 amongst the largest pharmacy chains in the southwestern states of Texas, Arizona, and California. The amounts paid for claims in Arizona seems disproportionately high, higher than Texas and nearly as high as the much larger state of California. The analyst would like to understand the prescriptions being filled in these states a little better. In order to do that, he realizes that having more information about the drugs being prescribed would be useful. Specifically, he would like to add therapeutic class information for the drugs to the report. While that information can be found, it is not yet available in the warehouse. Without Kaleido, this seemingly simple request might take weeks, but with Kaleido, the new requirement can be added quickly and with little effort from the technical staff. Working together, the warehouse architect and business analyst will add the requirement to the Kaleido business information model. While the business analyst describes what is required, the data architect will draw the new therapeutic class entity. Kaleido detects an error that the new entity is not non-aggregative, so it should belong to a group. Kaleido performs integrity checks on the model like this to prevent errors from being introduced. The architect drags it into the prescription dimension to remedy the issue. He then defines a hierarchy between drugs and therapeutic class by drawing a line between them. Definitions are captured in the objects drawn. While together, the business analyst and data architect can confirm the relationships are correct and mutually understood, and stored in a data dictionary that is maintained by the Kaleido product and shared with metadata-aware BI tools like Business Objects. The heart of Kaleido's automation is adding that change to the product simply by synchronizing the model as we have done here. We have moved to the Kaleido Dynamic Information Warehouse Explorer, a tool where warehouse professionals control the highly automated Kaleido warehouse. In it, they align data feeds to the model, create marts from Kaleido metadata, and alter the structure of the underlying warehouse reporting schema. In the Dimension tab, metadata from the model's dimensions are displayed along with the reference data itself. Here we can confirm that the therapeutic class object has been added to the model. but data to support the new West region analysis still needs to be brought into the warehouse. We already have a load routine for prescription drug reference data, so expanding it to include the therapeutic class data should be easy. As the warehouse professional opens the load routine, Kaleido recognizes that the business model has changed. This type of impact analysis happens automatically with Kaleido. The load routine prompts him before automatically updating itself for the addition of therapeutic class data to the prescription drug dimension. Moving to the Source Types tab and clicking the Launch Query Builder button brings him into a graphical query environment where the data to source the routine can be defined, either graphically above or by typing in the SQL below. Here we see the data that has been landed and is available for use. Let's bring in the newly landed data for therapeutic classes and join it to our existing drug load routine. Once we are satisfied, we can even preview our data to make sure it looks correct. Next, we need to align the new therapeutic class data elements to the business model. We do that here as a simple mapping exercise. We'll use one of the transformations at the bottom of the screen, Create or Modify BE, to add the new reference data for therapeutic class at the same time we are linking it to the drugs themselves. Kaleido will automatically manage the dependencies, loading the therapeutic classes first, then associating them to the existing drug records. With the load definition complete, he can save the changes to the feed and execute the load. This can either be done manually in the Explorer or in the Job Definitions tab, where numerous optional parameters can be specified. And that's it. Kaleido does the rest, managing all the complexities of integrating data, such as managing system keys, data change detection, validating the data against the business rules, managing history, and physical loading. Finally, the BI architect will add these changes to the business object's semantic layer. That semantic layer, called a universe, interprets the Kaleido reporting schema for the BI tool. He will simply move down the tabs of the Kaleido Universal Information Director utility and select the new therapeutic class hierarchy. Finally, he will update the Business Objects Universe file and publish it. Once the model has been updated in Business Objects, the new therapeutic class hierarchy is available for the business analyst. By adding therapeutic class information, we can see that a particular class of pharmaceuticals, opiate agonist, is the largest contributor to the high costs in Arizona. This process happens much faster with Kaleido by allowing reporting and analytics to better keep pace with the changing business.